today we are going to cover very important and core concept of Kubernetes. Okay, that is what is replica set, what is replication controllers, what is the difference. Okay, so basically we have the dev QA prod environment. Also there is scenario. So I have the e-commerce site and there is a sale is going on at weekend. Okay, so I need a number of resources. When the user increases, I need the resources. So in that case, I will set whenever a CPU or memory greater than 80% or any threshold, I will set. Okay, I will set the minimum and I will increase the instances. Okay, or I can create a replica set. Okay, replica set. So one application or one pod, I will create a multiple replicas of one pod. Okay, so it will run all time and it will distribute my traffic. So it will help to distribute traffic across cluster, provide the high availability, load balancing. Okay, then replication controller, both are same, but there is a slight difference. So replicas it maintain the set of pods, okay, whatever we define, whereas the replication controller ensure that the all is working, checks are working. Okay, and also there is difference. So we have the one more concept. So this is also important. So this is the some replicas we can call as a set based, we can call as a set based replicas or equity based selectors. So okay, so we are going to by some theory. Okay, so let's check theory. So what is the more about what is the difference and what are the difference between the replica set and replication controller and why we need replication in Kubernetes. Okay, so in production we need a replica set and replication controller, and there is no option for this. So I have made the nice document, okay, with the simple language and clear uh, difference. So why we need replication? A container or pod may crash because of multiple reasons. The main purpose of using replication is reliability, load balancing, and scaling. Okay, it ensures that the predefined pod always exists. Okay, so to prevent users from losing access our application, we would like to have more than one instance of our application running at the same time. That way, if one pod fail, we still have our application running on other one. The replication controller helps us to run multiple instances of a single pod in the Kubernetes cluster, thus providing availability. Okay, so that's why we need replication. So another reason we need a replication controller is to create multiple pods to share the load across them. Simple scenario, if you have a single pod serving as a set of users, when the number of users increases, we deploy additional pod to balance the load across the two pods. If the demand further increases and if we run out resources on the first node, we could deploy additional pod across the other node in the cluster. So replication controller spans across multiple nodes in the cluster. It helps balance the load across multiple pods on a different nodes as well as scale our application when the demand increases. That's why we need replication controller. So what is a replication controller? A replication controller ensures that specified number of pods replicas are running at any given time. In other words, a replication controller makes sure that a pod or homogeneous set of pods is always up and available. So what is a replica set? A replica set purpose is to maintain a stable set of replica pod running at any given time. As such, it is often used as a guarantee the availability of specified number of identical pods. The replica set are also known as a next generation replication controller. Okay, so replica sets check whether the target pod is already managed by another controller as well as like a deployment or another replica set. Okay, so what is the difference between the replica set and replication controller? So replica set and replication control do almost the same thing. Both of them ensure that a specified number of pod replicas are running at any given time. So main difference is replica set uses a set-based selectors which gives more flexibility while replication controller use equity-based selectors. So you have to understand replica set provide the set-based selector and replication controller provide the equity-based selectors. So let's take by example. Suppose this is syntax tire in and you want to add the replica set in front end and back end application. You have the application front end back end and you have the tire is the keyword. So you want to include replica set in both front end and back end application. So this will select the resources with equal to app and the value equal to front end and back end as it supports set based selectors. Okay. So three type of operators used in set by selector, that is in, not in, and exist. So only the key identifier. For example, I want to select the replica set for the environment in. This is the operators and I will include this prod QA dev staging. So it will run the replica set for the these environment. And tire not in, I don't want to include tire not in front end back end. Also, if I want to run the replica set for the web app only, so I will include the web app application. Okay, like this operator we have in a replica set that we call as a set based selectors. Okay, so here is the first selector will select the all resources with equal to environment and value equal to production, QA, staging or dev. The second example, select all resources key equal to tire and values other than front end and back end and all resources with no labels with the tire key. The third example, select the all resources including a label with key web app. No values are checked. Okay. So let's go by the replication control example. App equal to front end. If I mention app equal to front end, this will select the all resources with equal to app and value equal to front end as it supports equity based selectors. So what are the operators used in the equity based selectors? Equal to, equal to and not equal to. Here we have operators. Here we are using the keywords. Okay, environment in, not in, exist. Okay, the first two represent equity or simply synonym, while the latter represent the inequality. For example, environment equal to staging or tire not equal to front end, that I will mention. So let's create a one example. If I want to create a replication controller, okay, kind is a replication controller. This is my name. Replica I am running 3. Selectors and labels and selector is important to select the deployment and services. Difference between the deployment and service and replication controller, replica set, app equal to httpd, and tire I have mentioned a QA. Okay, so this is my labels. Okay, then this is my container image. I'm using httpd. Okay, and image pull policy, if there is not present, run the pull the images. Okay, running on port 80. So let's create a YML for the replication controller. Cluster is ready. Let's save the YML. Let's apply the YML. Okay, replica set is created for the HTTP service and for the QA environment. So let's check the replication control is created or not. So command is kubectl get replication controllers. This is my name of the replication controller. Okay, okay, it's running, and replication controller I have given the 3. Let's describe what is inside in the replication controller. So what information here? Namespace is default. Selectors are app HTTPD. Tire is the QA environment. Labels are this one. Okay, app and tire. Replicas are 3. Pod also running. Okay, port on 80, and this is from the replication controller. Okay, so let's check pod. Command is kubectl get pods. Pod are running. Okay, so what is next? Let's verify replication controller functionally by deleting a running pod controlled by replication control manually. The replication controller will automatically spam a new pod to meet the desired state. So if you accidentally delete the pod or something fails, so it will create automatically the new pods. So let's delete one pod. kubectl get pods. So let's delete first pod. Command is kubectl delete pod and my pod name. So let's verify if I delete the pod, it will come another pod or not. Okay, pod is deleted. Deleting. Pod is deleted. So let's verify another pod will came or not. We can see that pod number is 40 ending with 4062D is deleted, but another pod is came Z5WVW and age is 37 seconds. So this is the advantage of using the replication controller, and it runs or manage the load balance or runs on the entire clusters, okay, entire nodes. Okay, so one pod fails on the one node, so it will run on the another node. Okay, okay, so let's suppose I want to scale up the replication controller. So command is kubectl scale replication control, and I want to increase the replicas of right now it is running, I want to run it 5. So command is hyphen hyphen replicas equal to 5. So let's run this command. Kubectl scale replication controller replicas of 5. Okay, it is just scaled. Let's check whether the 5 pods are running or not. Okay, now I have scaled to 3 to 5. So let's delete the, this is the example of replication controller. So let's delete the replication controller. So command is kubectl delete replication controller and name of my replication controller. Okay, so let's create a example of replica set. So same application. Okay, let's create a YML. So here I have mentioned kind is replica set. This is my name, replicas of 3. Here match expression I have mentioned. Key is the tire, operator in, and the values front end. So I want a front end application. Okay, include, and it will run the replicas of 3. Okay, tire front end, and environment is a QA. Let's apply the replica set. Okay, replica set is created. Let's describe the replica set. Here you can see that in namespace is default, environment is QA, tire in I have included application front end. Okay, current is 3, running is 3, image port, and you can see the application replica set. Okay, so here only the difference between the set based selector and equity based selectors. Okay, let's check pod. Okay, pod are running. So let's scale up the replica set. It is scale. Let's check pod. So now the 5 pod are running. So if you want to auto scale, okay, I said that there is a sale is going on night weekend, I want to auto scale. So I can mention here kubectl auto scale replica set hyphen hyphen max equal to 5. You can mention the max equal to 10. So in our production we are using the minimum equal to 5 and maximum equal to 70. Okay. So like this, or some big e-commerce application they use the 100 to 100 thousands. Okay. So we can configure auto scaling for replica set to scale up to the maximum number of pods defined according to CPU load that the node is having. Okay. So command is this command kubectl auto scale replica set hyphen max equal to 5 and name of my replica set. Okay, auto scaled. So it enable or not. So in our production environment where you may have thousands of pod running, you may want to verify that the pod is actually managed by the replica set or not. So by querying the pod, you can get this info. So command is kubectl get pods, name of my replica set, -o yml grep -a 5 owner. So this is the command to check the replica set. Okay, it is managed by replica set or not. Run this command. Okay, let's okay, you can see that it is managed by and is the replica set. So let's delete the replica set. Command is kubectl delete replica set apps, name of my replica set. Okay, replica set is deleted. Let's check pod running or not. Okay, how is terminated. So one important note, so one should never create a bare pod with a label that matches the selector of replica set controller unless it template matches the pod definition, because once you create the replica set controller will automatically adopt it, and if you newly created bare pod specific and are different than the controller is programmed to use. For example, container is different. Okay, so you will lose data. So be confident that ensure that the labels are selected should match an image of the container. Okay, the recommended method to